John McCarthy. This gentleman could indeed be the software developer. Look at that beard. Developer of arguably the first functional programming language in the world, Lisp. This is an example of it over the side over here. Don't ask me what that does. I don't know Lisp. Apparently it's very cool. I understand it's still used today. Very nice, but anyway. So what is functional programming not? Well, the point of the last few slides was that it's nothing new. It's been around for absolutely ages. Most of those gentlemen did their work in the 1950s and 1960s, and the origins of functional programming date back to the late 1800s. I have indeed dug out some of those papers, but again, not a mathematician, so they caused my eyes to sort of steam over and some sort of strange liquid to start pouring out my ears. It was hard going because I don't understand it. But anyway, it's nothing new. It's not like the latest trendy framework coming out of React or Angular or whatever. It's not a language. It's a paradigm. And if you want a metaphor for a paradigm, if you want to think of a musical instrument as being a programming language, then the genre of music you play is the paradigm. You could take your guitar and you may play pop music, you may play rock music, you may play country and western if you have no soul. But the point is that you may play many styles of music with your same instrument. Similarly, with a programming language, you may program in many styles of programming. It is not imperative or object-orientated, those being the other two dominant paradigms. Most of the people that I've come across who've struggled with the concepts of functional programming tend to be those, like a lot of us here, I would imagine, who've been doing object-orientated for upwards of 10 years and find it a little harder to adjust to a slightly, new way of working. But most of the people I've come across who picked it up almost instantly tended to be students straight out of university. In fact, when I was in Minnesota giving this talk, I got chatting with the interns at lunch, and some of those said that actually this is what they're teaching in universities now as the way of programming. So to a degree, if we're not getting into functional, we might be left behind in 5 to 10 years. Who knows? It's not the solution to all of your problems, but I would argue it is the solution to many of them. Hopefully some or all of you will agree by the end of this. And it's not difficult. It's not difficult at all. It is a little bit of a conceptual leap for anyone that's not already gotten into it, but it's not actually hard. So what is it? What actually characterizes a functional language, a functional code? So important concept is immutability, and this is fairly common in functional programming. We've got a funky word for something that's not terribly hard to explain. Immutability is just that once a variable has been set, you may not change its value again, no matter what. Can't really do this in C#, but I kind of proceed as if this was the case. F#, absolutely, but that's a whole other topic. Higher order functions. Again, funky word, something that we've been probably doing for years. This is functions passed around as a variable, either as a parameter to a function or as a return value out of a function, but that's all it is. If you've been doing Linq, there you go. It emphasizes functions, not statements. What's a statement? A statement is an if, a while, for, all of those guys. There are other ways of doing this stuff in functional programming. Referential transparency actually just means that a function shouldn't rely on anything other than its own parameters. Seems simple, but it has some marvelous consequences. So the whole idea is that the function should become completely predictable. It shouldn't rely on any external state or anything else anywhere except for the things coming in. So it means that given the same parameters, you will always get the same answer out of that function, no matter what. No matter what state the rest of the system is in, no matter the life of the universe, no matter anything. I suppose you could turn a computer off, but other than that, pretty much, these same inputs give the same output. It's often called a pure function. Recursion. I'm assuming we're all good with recursion. Anyone who's not, speak now. Pattern recognition. I'll kind of get onto that in a bit. This is basically switch statements with knobs on. Stateless. So referring back to referential transparency, the pure functions, there is no state in functional programming as such. It's not like the object-orientated world where you have this object which contains the state, we modify the state, we track the state. This concept doesn't exactly exist in functional programming. Again, other ways of doing it. Monads. So according to Douglas Crockford, the curse of the monad is that once you gain the ability to understand it, you lose the ability to explain it. So I shan't. And it's not difficult. As hopefully we'll agree shortly. Where is it? So where can you find it? Of course, there are the pure functional languages, Haskell, Erlang. There are others. I know there's a whole load out there. I've heard great things. I've never personally used them. I've heard Erlang has been having a lot of success recently. I believe RabbitMQ is Erlang. So I've heard they're great. If you want to do them, go for it. Have fun. Enjoy. But not something I've touched on myself. Probably should at some point. I've also got some friends that swear by Haskell. So I think I've got a copy of the book around here somewhere. JavaScript. Would you believe JavaScript supports functional to a crazy extent that C# doesn't? I have another talk on that subject if anyone's ever demented enough to want to hear it. And C#, which is why we're here. So when is it? It's not that it can't do other things, but this is, generally speaking, where functional programming is happiest, where it's most effective. So data processing. Again, thinking back to your pure functions, then just this data comes in, this data goes out. Functional does that stuff really, really well. So if you've got like a rules engine or something like that, something that just chunks data from one form to another, functional does that perfectly and will probably do it better than nearly any other paradigm. Concurrent systems. So this is where you want to spin up a whole load of processes running in parallel, doing roughly the same task. Functional supports that really well because no state. Because most of the problems that you run into with async is things like resource contention, changes in shared state between threads, stuff like that. Generally speaking, doesn't happen with functional. High criticality systems, because a functional program tends to be more stable than the alternatives. It tends to be more robust. Erlang, I think Erlang's claim is something like, once their program is actually compiled and executed, it's nearly impossible to kill. And I don't doubt that. I don't doubt that at all. And serverless, referring back to the concurrent systems, if you're interested in something like Azure Functions or anything of that ilk, then again, functional programming is probably one of the things that's going to support that. So when is it not? Oh, someone mentioned AWS Lambdas. Thank you. Yes, same exact thing, except that that's in the AWS world. So absolutely AWS Lambdas. I'm pretty sure there's other instances of that serverless technology. Thumbs up to you as well. Okay, when is it not? So it can do these things, but this is where you have to make your compromises. So functional likes predictability, it likes stability, but these things are inherently not. So UI, dealing with files, dealing with input and output devices, external interactions with other systems, third-party systems, and I/O. You know, there is nothing more impure than a human being, let's face it. So this is where compromises have to be made, and the various functional or non-functional languages have made their own efforts to deal with this problem. But the image I keep in my head is that of a shadow. A shadow has two parts, the dark center, that's the umbra, and then the grey fuzzy bit around the outside, that's the penumbra. And what I like to think of is that we want to keep the umbra, the dark bit, the pure functional bit, as big as possible, and then push the non-functional fuzzy bit on the outside as far back as we can to increase the amount of functional that we have and decrease everything else. So at least we can maximize the amount of awesome code that we end up with in our system. So why is it? Why on earth should we be interested? Certainly these are my answers. It's concise. And that is not a small thing to me. You go from about this much code often to something little like this, which is marvelous because I am a very lazy developer. I don't like typing a lot of code. I like to just get on with my job as fast as possible, and functional is brilliant for that. It's readable, in part because of the concision. It's much easier to read what we've done. Plus, it tends to lay things out in a nice, logical fashion. I'll get onto examples in a bit. Extremely testable. I know for a lot of people, the testability is one of the huge draws of this. Thinking back again to the concept of your pure functions, it means that all the functions that you write tend to be extremely testable because they're predictable. They always give the same results for the same input. So throwing together unit tests is a doddle. Enables concurrency, touched on that. Robust, I've touched on that. And fun. I think it's fun. It's an awful lot more fun than typing out longhand, as I now tend to think of the alternatives as being. So moving on to the how of it, which is going to take up the majority of the rest of this talk. So this is a bit of non-functional code. This is the sort of thing that well, certainly people like myself who've been in this game a long time have tended to write a lot over the years. Incidentally, anyone who can guess what the titles over here in the corner are is automatically one of my friends. But I will give you like 5 seconds to work out what on earth this is doing, and I bet it would take an awful lot longer. Some of those folks that have been doing this longer than I have will probably get there quicker because we've done it so many flipping times. But my point is that we've got an awful lot of code here to do something that's relatively simple. The logic is split in many places. It might take a bit of staring to work out precisely what it is doing, or could rewrite it like this. Incidentally, for anyone who's playing along at home, those are the episode titles of the very first season of Doctor Who from 1963. Doctor Who, for those not aware, is the greatest TV series in the entire world, and I will fight anyone that says otherwise. Fight ya. Right. But my point is that this is functional programming. Now, if anyone is about to think at this point, well, that's just a bit of Linq, yeah, it's totally a bit of Linq. Linq is functional programming. And that's a deliberate choice on the part of Microsoft. I was here, well, I say here, I was the real here, NDC Oslo, about 2 years ago. And there was a talk there from the head developer of C#. He keynoted. And I asked, what's the intention with the functional content in C#? And his answer was, what are you doing in my room? But after I had been tied up and beaten and the police had been called, then the explanation was that the intention is that my C# is a hybrid language. It is absolutely going to support functional programming going forward, and every iteration of C# going on is going to contain more functional content than the one before it. The F# guys and the C# guys are mutually benefiting from this increased functional content. So it is absolutely the way that they're moving the language. So here, if we look at these of course are shorthands for functions. These are functions being passed as a parameter. That's functional programming. That's how it works. And that's all of this does. So if you're comfortable with Linq, then hopefully there's not going to be anything in the rest of the talk that will boggle your mind too much. We've got a couple of questions. Okay, Stian says he's interested in game programming. Unity is his tool of choice. They've been lately focusing on a new paradigm, DOTS, Data Orientated Tech Stack. I have never heard of this. I think I might have to hit Google once I get back. But he says, from what I've said, this is functional. That's cool. Might be. Don't know. That might have to be something I look up later. And someone has asked if I could see how one should think differently when unit testing functional code versus OO. Good question. I'm not exactly going to touch on that, but maybe bring that up again at the end, and I'll see if I can put together some thoughts. Okay, so you could even go a step further on my comment on my previous slide, and you could start throwing in some things like this if you wanted. So I'm just storing some funcs. I'm guessing that everyone is okay with funcs. If you're not, it's going to be a tough lecture for you, sorry. But you can store your functions as variables here, and then you could quickly and easily define each piece separately of your program. So a split on comma here, which literally does that and nothing else. A parse data, which just does that and nothing else. And then you could stuff this all together into something that reads like this. So and then another function is just placing it all together. So now that reads almost like natural language. I could probably show this to my manager, and now they might not be able to modify this or entirely understand it, but roughly speaking, you can understand what this does even if you're not all that technical, because it's not fundamentally all that different what you're seeing here. And it's got lovely descriptive words. So this for me is a huge benefit of functional. You tend to end up with stuff that looks like what you're trying to do. Whereas your old for loop with a list view for me is probably more what's happening behind the scenes once the compiler's messed with it. But I'm not interested in that. I don't really care how it works. I want to know what it does. So this is a big old block of code, which might be familiar to some people in the UK. These are the validation rules for what's called a NINO. Now, I used to do work for HMRC, that is the tax revenue people for the UK, so I am very familiar with the national insurance number. Don't even get me started on what those things are, but there's a whole long list of rules which define whether a NINO, a national insurance number, is valid. It's down to which characters go in which space within the number, which are letters, which are numbers, which letters you may have. There's a whole load of rules. And in this case, the structure of this code is that I am checking each rule. If a rule fails, as in that rule isn't true, then I'm returning false early. And then, it's kind of missing off the back of the screen at the moment. That's rubbish. Otherwise, if I go to the end of all these rules, then I return true. Awesome. Or I could write something like this. So you don't have to actually separate out everything like this, like I have, but I just kind of like to do that sort of thing because it makes it an awful lot easier to read what's going on. But all I've done is I have separated out each rule into a line here. So it must have length of 9. There we go. A nice simple definition of a string having a definition of length of 9. You could blend this all together. I don't really mind. Must start with an alphanumeric and so on. You could see it's pretty clear what we're doing here. But I have stuck all of these functions into an array, which is a subtly powerful thing to do because you start finding all sorts of fun ways to play with it once you've done that. Because you could apply Linq to the array of functions. And here we've got an all. So what does all do? All is a Linq feature. What all does is go through each item in the array, run this, and if every single one returns true, that's good, we'll return the whole thing true. If at any point any of these individual things return false, then we just terminate the whole process early and return false. So all I'm doing inside the all lambda expression is feeding it the NINO string with any spaces replay. Someone's just asked for a link to the slides. I will absolutely put a link at the end to the slides. No worries. I think there's plenty. If you have a dig around on Twitter, you'll find a million copies of my slides around there too. But don't worry, I will make sure that everyone gets the slides who wants them. So my point is that this all has completely replicated all of the structure of code on the previous slide, which was about this chuffing long, only I'm doing it in this little statement here. My return early, my final return true at the end, all of that. Easy peasy. And if you wanted to get rid of all these guys, you could just merge all of these into here. Job's a good one. So, yeah, why make things hard? Why write all those lines of code when you just don't have to? And in fact, I could do something like this if I wanted to. Now, I'm assuming that everyone is good with extension methods, because once again, if you're not good with extension methods, it's going to be a tough hour for you. So I like extension methods. I think they get a bad rap. There are ways of using them, and there are ways definitely of not using them, but I keep them small, simple, and generic, and that's what I'm doing here. So I've created a validate extension method, which attaches to a T. I've called it T input because I like clarity, but that's still a T. So attaching to a T means it attaches to everything in the whole of C# with no exceptions. And I'm taking a params. I love params. Params is awesome. If you don't use params, you should. And So what I'm saying is, give me a whole list of predicates, that is validation for rules, taking t as the input and bool as the output to tell me whether it's right or not. And then you could just do this. So I'll do my replace just the once, I'll call validate, and then I'll feed it each rule. So once again, we've compacted down the code a little bit smaller. We've got a reusable set of validate function features here, which we can apply all over the place. So just made, for me at least, C# a little bit friendlier and easier to use. If you really wanted to, and I'm not going to dwell too much on this slide, but you could go and break down each of those rules into little sub bits of rules. So you've got all these sorts of reusable pieces, like you could have a generic has length of, and you could feed a 9 into that if you wanted. There's all sorts of ways you could break this down, but in principle what we're doing is turning functions into Lego bricks, and we're breaking them as small as possible and allowing us to stuff them all together to build up our little Lego castle or whatever we want to make. And then you'd end up with something like this. Does that suit you better than the previous guy? I don't know. It's certainly very generic and very readable. And if you wanted to maintain this thing, it would be very simple to throw in an extra rule. If you wanted to take a rule out, again, just delete a line, job's a good one. It's clear what the rules do. If someone comes back and says the rules aren't right, you could just literally show them this code and say, what's wrong in this description? And they, the non-technical person, could probably tell you, oh, hang about, it's actually the characters between 2 and 7, not 2 and 6. But bang, job's a good one. Right, moving on to the sort of programming exercise we may have seen before. I'm going with bank accounts. So I've got my standard bank account with a balance and an interest rate. I'll imagine that we inherit off that with a super duper bank account, which has got the bonus interest rate, and the dodgy bank account, which has got a brown paper bag stuffed with money, probably left in a car park. Now, I usually make some sort of comment about a certain politician in the news, whoever happens to be in the news at the time, but these days, take your pick. I give up. Right. And this is the sort of functional way of handling applying the interest. Now, obviously, this is a grossly simplified version of applying interest, but this is just out of the box C#8, I believe it is, where we are casing on the type. We're actually casing on which type it is based on this BA is referenced previously as being the sub to the master, the parent class, which is the standard bank account. But if you case it based on it's a dodgy bank account here, then it will actually be automatically converted into a dodgy bank account here if it is in fact one, and then we can run our rule here referencing this local variable without any worrying about checking against types or anything like that. We've done an awful lot of if type of equals blah blah, all sort of compressed into this. And again here, if it's the super duper, and I could even put a when in here to say if it has this particular balance. So this again is out of the box C#. In fact, I think this may even be slightly out of date now. But my point is that this is functional programming again. This is pattern recognition. This is kind of what it looks like. If someone says if this doesn't turn into a C#8 switch, I would be disappointed. Sorry, Stian, you're going to have to be disappointed. I think this slide is maybe slightly out of date. Do look up C#8 switch patterns because they're even more powerful than this stuff. But this is all that pattern recognition is. So, yeah, do look into this stuff. And I do believe that their intention is to take inspiration from pure functional languages and add further content of this type as we go along. So, another bit of fun with arrays of functions, Now, this is a super stupidly simplified version of applying tax to salary. It never really works like this in the real world, but this is loosely based on the UK tax system. And what I have is a series of rules. And based on what your salary is, I decide which rule to apply. Now, this would probably involve an awful lot of if statements if I had to write this out longhand. But here what I've got is an array of tuples, each of which contains a func2 functions. I'm again assuming that everyone is good with tuples. But on the left-hand side, we've got our condition selector. And on the right-hand side, we've got the actual rule to apply. So that's just a tuple where we've got decimal bool and decimal here. And down here, I'm doing a bit of Linq to say do dot first. And dot first is saying, get me the first where the condition, that is the left-hand one, when you feed it the salary, returns true. So what that will mean is it will go through these one at a time until it finds one that returns true. So if you have a salary less than 11,850, then it'll select this one out. Or if you've got a whopping great salary over 150,000, because wouldn't that be a lovely thing, then it would select this one out. But it's selecting out at this point the whole row. So then what you have to do is call the calculator. I've called it calculator, which is the second half of the tuple, and then feed salary into that. That took me an awfully long time to explain. But actually, once you've got that concept in your head, understanding this, looking at it is not all that complicated. We've got a set of rules, we've got the transformation to apply, and it's not all that complicated to write. Excuse me. So, moving on to some other functional structures. So let's imagine for a mo that we've got two different sources of data. We've got a hypothetical database operation that returns some data, and we've got one that returns a null, for example. Ludovic says, very cool tax calculator. Thank you very much. So I don't know what these could represent anything. Maybe one of them's an XML, maybe one of them's a web API lookup. Doesn't really matter. I don't really care. Use some imagination. So I am saying that I want to feed in, let's say, my name, and then I want to get out some data. And this structure here will allow me to try each one in turn and then actually return out the one that works. So normally I would have to do things like null checking and stuff like that. And this is a way of getting around all of that sort of annoying code bump that you have to put up with. So I'm saying here are two functions. I don't know which one's going to work. Try each one in turn and then bring me back whichever one works into here. And I don't really care, except that I will now assume that it works. And how does this actually work? It's kind of like this. Alt is as good a name as any for this. I've heard. Now, something you may hear me saying quite a bit over the next few slides is a lot of these things have got many names. I've gone with one name that seemed like a good name to me. Feel free to call it what you wish, but I've heard this called alt. I believe the proper name for this sort of structure is a functor, I think. So this is as an extension method. I'm taking a t input again. That's everything. And then I'm saying, here's some funcs. I've got F1 and F2. And I've also created another structure down here called if default do. Now, this takes this takes the func, which is the else, and it takes an input. So what it does, it says, this, by the way, is the slightly terrifying generic way of checking against null, because once you go into generics, of course, not everything is null by default. If it's an integer or a boolean or whatever, they default to different things. So this is checking against 0 if it's an int and so on and so forth. So I'm saying that if this thing is null, then take the else function and run it with the input. Otherwise, just return whatever it was, the thing that wasn't null, shove it back again. So that means that I will now say, function 1, run function 1, pass it the input. If default do. So if function 1 executes and we get out a null value or equivalent, then execute function 2, passing in this. If this came out with a value, do not execute function 2, and whatever the result of this guy was, return it. Again, took me a long time to explain it. Pretty simple in practice. This is another similar structure. This is a fork. I could make some sort of rude joke here, but I shan't. I'm better than that. And hypothetically, this is an input, and I have chosen a deliberately, stupidly simple example. I don't know why you'd ever want to do this in the real world, but again, I don't want to get bogged down in the logic of what I'm trying to accomplish. I'm just trying to illustrate a technique. So hypothetically, I want to go and count how many A's, how many B's, and how many C's are in this input string. And I want those all to be done separately. So I'm going to do .fork. So a fork is kind of like, it's got prongs and a thing linking them together. So each prong of your fork is a different function which is doing a different operation on the source input, the same input. Each one of these prongs is acting on the same input and doing a different thing. And then this function here sticks them all together. So because I'm using a params and stuff, I've had to put the sticker together thing at the beginning, but that's just how we have to do it. You could do all sorts of alternatives if you wished. And what I'm doing is just summing them. I mean, maybe you wouldn't really sum them. You could do all sorts of other complicated operations. It doesn't really matter, but you get the idea. Single input, split it into multiple functions which run separately, back into a final output at the end. And how you do it is something like this. Map, incidentally, is one of the greatest little tools in C# that you never knew that you missed. And all it does is attach to everything and then take a function which converts whatever this is to the next thing. Just means that you can basically do Linq, but instead of selecting and applying to each item in the array, you're selecting based and transforming the whole object. I just find it means you can compact your code an awful lot tighter. So I'm saying that the prongs are a params taking function of input to output, and we're selecting them based on whatever the transformation function is, and then mapping with a join function. So, passing in the parameter, and then using the join function to stick them all together again. Now, you could go as complicated as like this stuff. I have written fork functions which had multiple stages because I wanted to convert from type to type to type. You could do all that sort of thing, but this is the simplest possible explanation version of this structure. So, I mentioned currying briefly. How do for time? Good. Right, currying. Someone just asked how async can await with playing with this forking. It would play very well indeed. I haven't actually written an async version of it, but I would imagine that you'd probably just put in a wait inside the extension method and have that wait for each of the prongs to complete, and then return a result at the end, and you'd make the whole thing async. I mentioned right back at the beginning, but things like async are very well supported by functional programming. So it plays very, very well with that sort of thing. Currying. So this is a hypothetical normal function. This is an add, a plus b. Wow, that's simple. Give it a 10, give it a 20, we get back a 30. Ooh. But let's imagine that this was a curried add function, and I only give it a single parameter. What do I get out of this if I've only given it one parameter when it takes 2? The answer is, and by the way, this is a rule of thumb with functional programming, if there is a question, the answer is functions. Mostly works. And yes, the answer is you get out nothing because there we go. We get a function. So we give it one parameter out of the 2. What we get back is a function which represents the base function, but where one of the parameters is now filled in. So by giving it a 10, it has now become an add 10 function. If I give it a 20, it would now be an add 20 function, and so on. We could store that locally. It means that you can take a great big long function with loads of parameters and apply them piece by piece and reuse each piece of it multiple times if you wish, without writing a whole load of similar but not quite the same code to accomplish various different means. So, question on everybody's lips, I am sure, is can you do this in C#? Bit, sort of. This is probably the most effective way I've found to do it. That is, what you notice here is that there are 2 arrows. So this is an arrow function returning another arrow function. So this does indeed do roughly what you saw on the other page. If you pass a 10 in to this, what you will get is this arrow function back, where this x has now been filled in with a 10. And so long as wherever you've stored the call to this is still in scope, this whole thing remains in scope as well. So, excuse me. Do watch out if you're writing this sort of thing, the order of operations is important. So that, of course, has to be a y minus x. So you absolutely can. That's the easy way. Does this have its uses? It does. It can kind of prettify some of the code that you might write elsewhere to add in more sort of descriptive language. I have seen other ways of doing this in C# with extension methods, but I can recommend a book which talks about that sort of thing. It looks pretty ugly behind the scenes, but it does work. So it is possible, but it requires an awful lot of malforming of C# to make it happen. So this is a parser, back to our Doctor Who. In fact, I want to talk about some of this stuff in a minute. So this is, excuse me, a func, which is parsing these Doctor Who stories. What I'm doing is taking A, B, C, and D. So A is, I believe, the whole string. B is which character do I split on? In the C is which of these three fields do I actually wish to extract? And D is the source data itself, I think. Yes, D is the actual source data. So the string itself. So, excuse me, how can I actually partially apply this stuff? You'd have to do something like this. I have created an extension method called apply. So first off, I am calling the func and I'm calling .apply. How apply works, I'll get to in a minute. I'll show you. But I am passing in 2 parameters out of the 4. This means that this parse here has now become a parser which, given any amount of any strings at all, will split on new line, then split on comma to create an array of arrays, a 2-dimensional array. And I can reuse this one as many times as I want. If I've got a whole load of other stuff to be processed elsewhere, I can just reuse this same exact thing. And I don't have to write separate functions to do it. This handles all of it for me. Then I'm going to write a function here, which is taking the parse and then just passing in one function with the apply, and it's saying 0, 0 being the 0th position out of the array, which is the story codes. And then if you pass in this string into here, these new lines are just here for the sake of making this readable, then you get back A, B, C, D, and so on. Basically, piece by piece, I've created separate reusable functions, which I have partially applied to, and I get back a list of the story codes. Here, I've referenced parse again. So without having to write another parser or write another block of parsing code, this time I've partially applied but given it a 1. So without writing any of the code, I've now got a function which will blast through this, break it into lines, break it into fields, select out the 1th position, which is the story title, and then return it. So it means that you can write one function which does everything, and then use something like apply to apply in the parameters piece by piece, and then reuse each of those pieces wherever you wish, without writing an awful lot of vaguely duplicated code. What apply looks like is something like this. Now, I did say it was ugly, and it is. Yeah, I'm not going to dwell an awful lot on this, but basically you're saying, given a func with this many parameters, I'm going to return back a func with fewer parameters, and I'm going to stitch in the appropriate bits myself when I return it. It means that if you wanted to do this method, and by all means do it, it means that for every combination of how many parameters in to how many parameters out, you're going to have to write one of these extension methods. So potentially an awful lot of writing. I don't think it's necessarily a useless endeavor. It can mean that your code can become an awful lot nicer. It's just that I would probably shove this in a code file somewhere way at the back of the code base and try and pretend it doesn't exist. But why not? So, last phase of a functional flow. This is a typical functional flow. We start off with a string or whatever. It doesn't really matter. We start off with one thing. And then typically, at first instance you split it up into many things. Functional programming works in many ways more like TSQL or similar, where we're applying list-based operations to a whole load of data in one go. So we'll do some wheres, we'll do some selects, we're converting types, we're doing all sorts of stuff. And then the final method is aggregate. So we're aggregating many things down to one thing. And the traditional method, of course, is to have something like a list, which we're appending to, or here this is a string builder, same principle, loop through, append, loop through, append, or just do a string.join, which is the really nice, simple way of doing it. And this is more the functional way of thinking. This is a whole load of story data, again for Doctor Who, because Doctor Who is the best. And I've got things like the ratings, the number of episodes in that story, because back in the old days, Doctor Who was always multiple episodes for each story, and the number of missing episodes, because tragedy, there are missing episodes of Doctor Who. There are, I believe, 97 missing episodes. If anyone's got them, hand them over. I want them. But there we go. That's the way it is. So what if I wanted to aggregate a whole load of data out of this? I feel like I'm almost telling you something that's simple here, but I have been astonished by how many people don't know about this. But obviously, you've got your extremely simple basic aggregators. We've got sum, pass in a function to tell it what to sum. Similarly, I've got average, pass in a function to tell it what to average. And then we've got our more complicated aggregator. And again, I'm astonished how many people don't know about this, but it is, I think, one of the coolest things in C# next to dictionaries. Dictionaries are actually my favorite thing in C#. I love dictionaries. So what is this aggregate doing? Well, first we give it a seed value. Now, in my case, I'm giving it a tuple of 0 and 0. So it's 2 integers with 0 and 0 as the starting values. And then I am passing in a function with 2 parameters, the accumulator and the current value. Call these as you wish. This is what I tend to go with. The current value is just like your x in a normal Linq expression, in a select or whatever. That's the current value coming out. That's each item in the array, one after the other. And the accumulator is the running total so far. So the first time this operates on the first item in the array, it's 0, 0. This function then tells the next accumulator what the value should be. So we take in the accumulator item 1 and then add to it the current number of missing episodes, and again on item 2, and then add in the number of episodes. So piece by piece, what we're doing is blasting through this and creating a running total of how many episodes in the story versus how many missing episodes. Other way around there. And then we can do a percentage at the end. This is ridiculously simple stuff, and you might possibly not entirely want to do something so simple with aggregation, but again, I'm keeping this simple just to demonstrate the technique. You could imagine passing this all sorts of complex objects and then doing operations on them to reduce them down into an answer at the end. And I would probably not let this get too complicated without breaking it off into subfunctions anyway. But you get the idea. So this is incredibly powerful. It means that you don't have to, generally speaking, you don't have to do that for each with a list or anything like that again. You could probably do something like this. I've used this a great deal, certainly in my day job and in things like, if anyone's familiar with the advent of code, I do love the advent of code, and I use this sort of thing an awful lot in that. So, I don't really have time for this. This is a bit of head-meltingly complicated code, and I saved this for user groups when I have to talk for longer. So if anyone's interested in seeing a bit of insanely complicated code, talk to me afterwards. Right, last piece, I believe, and then we can all rest, because I believe we're running out of time. Right, Fahrenheit to Celsius. I used to work for an American company, and one of the things that we often used to talk about, because I am British, is the weather. It is not a cliche. We really do talk about the weather a lot. Mostly because it's so flipping unpredictable over here. So they would say to me, and I'm not doing the accent, I can't do it, it's embarrassing. How bad my accent is, that is. Right, they would say to me things like, it's 100 degrees outside, and I would think, whoa, 100 degrees outside, that sounds like you should be dead. But no, that's in Fahrenheit. Working out on Celsius, I think it's something like 32, which is, yeah, it's quite nice. Right, what is the process for converting Fahrenheit into Celsius? Well, it's deduct 32, multiply by 5, divide by 9. Of course it is. Wow. So then I'm doing some rounding because I don't want a great big, long, amazing, super detailed decimal. And then I'm formatting it here nicely into something with a degree centigrade on the end. So what's a nicer way of rendering all of this lot? This is a structure called an identity. Let's not dwell too much on why it's called that. It's got lots of names, or too much about the detail. But what you have to bear in mind here is this is an identity of T. So this is of type anything, doesn't really matter what. And inside here is a value. It's a T. It's a T, and it's called value. So it's a thing in a box. That's the only thing we need to worry about. Thing in a box. We got a box. Inside is a thing. The thing is our value. Easy. I got a couple of little bits of syntactic sugar down here, some implicit operators. It's just because I'm far too lazy to do all that typing. and I have got, because I'm being a functional programmer, I'm not letting you change it. This does not have a setter. The only way that you can set it is in the constructor. So, a couple of extension methods. I'm creating one called toIdentity, and this is attaching to everything, and all it does is whatever the thing that you just called toIdentity on, it takes that value, whatever it was, and stuffs it in the box. So now you've got the thing in the box. And then bind. This is where the magic happens. Bind is not all that different to the map function I referenced earlier. So this again attaches to all identities. So once you're an identity, this bind will now attach. And all I want from you is a function which takes the old one and turns it into the new one. So that's my multiply 9, my divide, whatever. That's the thing, the process. And then whatever that function is, I'm going to run it. And then whatever it comes out of it, I'll stuff it inside another identity. So take your function, take my thing out of the box, run it into your function, pull out the new thing, stuff it into a new box, give it you back. And now my Fahrenheit to Celsius looks like this. It's a nice, orderly chain of operations. So I have also used, I did mention that they have their uses. My curried adds and subtracts and all that sort of thing from earlier, I've used them here. Now, if you wanted to, you could do something like x arrow x minus 32, but I don't know. I kind of like to make my code very descriptive. So each bind is running the function I pass it. So these are functions. These are functions. These are exactly the same as arrow functions. I'm just writing it in a descriptive way. So this bind says take whatever the input is, run this function, which is a subtract 32 function. Take that, whatever it is. If I started with 100, then what does that make it? Oh god, my mental arithmetic, it's so bad. 68, I think. And then stuff that inside another identity, which can then be called with another bind, and we do another operation. And because I've made it T input to T output, you can convert type to type as you go through this chain. Otherwise, we might have to add an awful lot of sort of little local variables with different with the different values in as we go along, and you'd end up with all these little local variables that you'd have to just chuck away. Someone says more sound effects. Right. The name for this kind of structure is a monad. I said I would not explain what they were. I lied. This is a monad. This is just about the simplest, stupidest monad that you can imagine, but it is in fact a monad. So what is a monad? Someone just said this is the equivalent of piping in a command prompt. Absolutely, exactly the same concept. If you understand piping in the command prompt, basically you understand monads to a degree, but that's all a monad is. It's like a relay race. You've got each person passing the baton to the next, except that each person's not just literally passing unchanged, they're doing an operation, they're multiplying, they're dividing, they're, I don't know, chunking it up, whatever it was you want to do, and then passing the new version to the next person, and then so on. That's what a monad is. It's not that hard, is it? I think that's quite easy. And this is something else that you might possibly want to do if, like me, you grew up in the 90s and you think you were cool. You might want to replace various letters from your name with letters to make it Leet, because Leet speak's still cool, isn't it? Isn't it cool? It's cool, yeah, still cool. So I've created another monad called maybe. I'll get onto it in a minute, but same principle though. I'm binding with all my various functions. My first bind is take the ID here, which is, for the sake of argument, an integer. Probably doesn't want to be an integer in real life, but that's going away to a hypothetical database and coming back with the value. And then we're like taking some details, first name, last name, and age, and then I'm replacing A's with 4s, E's with 3s, I's with 1s. There's probably a function here that will take your baseball cap and put it on backwards too, just to be even more cool. But the problem is that getPerson2 here might not necessarily actually return a value. Person ID 12 might not exist. This might come back as null. So if that were to happen, well, what happens in this bind when this operates? If X here is null, someone says missing T to 7. Yes, you're right. I need a T to 7. Darn it. Right. But if this comes back as null, then this is null. This is null. This explodes in flames. So that's not good. So it says, how will we know if we're Leet? Yay, you can't. You're just exploded. Poor you. Right, but how can monads rescue us from this scenario? It can, with the maybe. So this is the maybe. So we've got now we've got this here is the equivalent of our identity before. Thing in a box. Thing in a box. And this is called maybe. It's an abstract though. I do not ever want you to actually instantiate a maybe, not directly. And I've got an abstract t value here. Another implicit operator because I'm just lazy. And I have implemented it out into two subclasses. Now, I've heard these called all sorts of things. I've heard maybe also called option. I've heard so just also called something. Nothing's pretty consistently called nothing, though. Fine. But anyway, you may find these under different names. It's all the same concept. But this means this just is an instance of the maybe where the operation worked. And this is an instance of it where it didn't work. The just here is exactly the same as an identity. It's just thing in a box. Carry on like normal. The nothing, on the other hand, here, this overrides it. And I don't know if you can see, for me, my video is blocking that, but that's default. So I'm overriding t value, and I'm saying that is just the default. It's 0 if it's an int, it's null if it's anything else. You get the idea. And those are the two possible states that my monad can exist in. Something or nothing, just or nothing, whatever. Call them what you wish. And this is how I actually implement it. So I've still got my two maybe, which is exactly the same as my two identity. That's just take this thing, turn it into a thing in a box. Easy. But I've got a more complicated maybe now. The parameter's the same. A func that takes old type to new type. And the maybe, which is the this. And I'm switching on it. I'm switching on this, the maybe. And first I'm casing that I am saying that I'm casing that it is a just. That is, it does contain a value currently. When, and this is again the default check, I'm saying that it's not null. So this case is assuming that the previous operation worked and that we got a not null value out of it. If that's true, we'll go into a try-catch statement and we'll actually run the function. If it explodes, then we'll return a nothing. If it succeeds, we'll return out something, but it might be that it contained null, in which case the next time that we execute this, we'll check it. And if it's null, or if it's already a nothing, then we just do no operations at all and go straight to nothing. So the best explanation I ever heard of this was from the website F# for Fun and Profit. Marvelous website, not just for F# developers. There's some very nice conceptual articles. It's Scott Vlashin, I believe his name is. And he described this as something like railway-orientated architecture. Now, this is a metaphor I love a lot, and I'd recommend that website. But imagine that you've got, there we go. Imagine that you've got two sets of train lines. You've got the something line and the nothing line. And every function is a set of points along the line. And at every set of points, we check, is this still working? Is this still working? If at any point it doesn't work in any way, we switch. We switch from the happy line, the just line, the something line, over to the nothing line, and we just coast all the way to the end. So that means that any functions after that point are not executed. It packs in an awful lot of functionality, but doesn't actually require much thought once you understand it, and gives you an awful lot more. I just want to just put the F# Fun and Profit link in the in the chat there. I'll probably try and share those in my notes afterwards. It's a very good website. But yeah, so the point is that things like try-catching is now baked into the data, into the structure of our code. Checking against null is now baked into the structure of our code. Those are two things that normally we'd have to do time after time after time in order to make sure that our code stays robust. But now it's just here. We don't need to anymore. Turn it into a maybe, call bind, the null check and the try-catch are just fundamentally provided for you. And in theory, you shouldn't ever be having any more exceptions ever again, which is nice. How are we doing? Ooh, out of time. Okay, I'll just blast through this really quickly because we're about out of time. But this is a slightly more complicated version again. This is either, and roughly the same idea, except we've got a left and a right. I've heard these again called all sorts of things. Your right is your happy path, your right hand of justice, your left hand of evil, left hand of darkness. It didn't work. But it's roughly the same concept as the maybe, except in both cases, I'm catching the value. I'm still maintaining, oh, no, I'm turning that into a default, except with the left-hand path, I am also capturing the exception. So I am saying that if an exception occurred, we'll shift from the right-hand path of true justice to the left-hand path of evil. We'll grab that exception, whatever it was, we'll glide down to the end, and then you will have the exception captured, and it's all just there at the end for you in a single value. That's what it looks like. It's roughly the same. I can think of all sorts of ways to make this a little bit more interesting and capture some more useful data, but I'm just keeping things simple. Oh, and I would probably have this returned as the return value of a function, as in I'd probably have a function return an either or a maybe or whatever to signal the fact that there is some uncertainty as to whether this will work. And then I'd probably use something like your switch statements to switch on type to determine, like, okay, now I know what to do if it worked or if it didn't. Oops. Someone has asked in the past whether there are any libraries out there that already implement a lot of these structures. There are. LanguageX is the only one I'm aware of at the moment. I think there might well be others. I had a little play around with LanguageX. Seems pretty good. There's some of my examples reworked into LanguageX. They call bind map, but it's the same basic concept. And they have a match at the end, so it's like you have to go into the map world of doing the binds, and then you call out of that world by you defining a match, which collapses based on which of these functions are called into a real value. All seems pretty good. I've had a bit of fun playing around with that. I personally like to just implement it myself. Might be a little bit of extra work for me, but I like to understand what's going on, and since functional is relatively new to me, although I've been doing it for a few years now, I like to actually get my hands dirty and implement it myself to make sure I understand what's happening. Further reading, and I promise you this is the last slide. You can all breathe. Right. Functional Programming in C# by Enrico Buonanno. This is one of my favorite programming books of all time. It's certainly one of the best that I've read in years. Some of the examples that I've given were based on some of the material in this book. I love this book. I have been occasionally badgering him on Twitter to try and respond to me, but he never has. Curse you, Enrico Buonanno. But it's a marvelous book, and if anything that you've seen here seemed interesting or fun to you, I thoroughly recommend this book, if nothing else. I loved it. Functional C#, Vishnu Angoro, apologies to him if I'm mispronouncing his name, is pretty good. I like the Buonanno book better, but this one's nice as well. There was a YouTube video which kind of started me down this path. Well, I say YouTube video. This was a talk at NDC Oslo many years ago, which I was actually present at. Kathleen Dollard. This is a nice one as well. And she touches on some ideas I haven't, like having, say, one global try-catch for the whole application. That's lots of other nice ideas. I recommend this one as another starting point. There's a couple of Pluralsight courses. They're not bad. You could go on to F# Fun and Profit, Scott Vlashin. Absolutely. I like the website. If you really want to go hardcore and go all the way, pick up a book like Learn Your Haskell for Great Good. I have a friend or so that swears on this thing. Go for it. Now, any questions? Eerie silence. Ooh, someone's put a review up for that book. Functional programming can make your head explode. This book stitches it back together. I like that. That's quite nice. Oh, fantastic. Thank you, Ryan. Yes, Malika has just prompted me that I didn't ask about unit testing. Okay, my brief thoughts about unit testing. Because functional programming, when it's done properly, relies entirely on pure functions, that being a function which may not rely on anything except for its own parameters, you could basically do a whole load of unit testing without actually doing any mocking, potentially. You just pass it in some values, which you just feed it directly and then get back out the answer. The whole idea of passing in mocks to go and get data which are executed by the function, that would be anathema to the functional process. So the more that you write your functions based on this idea of purity, the easier it'll be to just unit test everything. So try and stick more to that. Try and think more in terms of splitting down your functions into smaller pieces, because again, functional programming tends to work better when you've got small pieces rather than a lot of the stuff I've seen in the object-oriented world where you tend to get like functions that are thousands of lines long, and I've seen some of those guys, and have gigantic messes of ifs and ifs and ifs that look like family trees. Because in functional programming, you're sort of writing these nice little flows, you tend not to get into that mess, and you tend to end up with nice, clean, small, easy to understand functions that are easy to test because they've got often a single purpose. So just by following this paradigm, it tends to push you down a direction of easier testing. Someone has. Oh, what we got? What we got? Oh, someone said, "What about the complicated part?" Well, I hope everyone feels that this is not too complicated. The stuff that I've been saying, I don't think it is. Of course, yeah, it's quite easy to go down some strange rabbit holes sometimes with this stuff, as always. But oh, someone asked about the bit I skipped over. Sorry, yeah, maybe not while we're on the recording. But if anyone's interested, grab me and I'll give a quick talk about that. It's a sort of head-meltingly nasty bit of code I wrote that does some strange things, but yeah, it's a sort of example putting it all together. Is there a Git repo with these examples? Git repo, there might be, but certainly the slides, yes, I will put up a link to the slides. I've got it on Dropbox. I'll probably pop it on this conference room. Also, I am on Twitter @MadSimonJ. Grab me there. You'll probably find copies of my slides around, and I shall probably put the link there too. So, someone asked, do I mix and match programming paradigms in the same project solution? If it's C#, yeah, probably. I try to maximize the amount of functional that I do, but C# being C#, sometimes you have to make compromises, and it's just inevitable. But to be honest, by and large, you could write an entire application exclusively in functional in C# if you wished. Does mean writing a load of extension methods and jumping through some hoops, and I'm not sure if it's always going to be optimal. C#'s not necessarily optimized for functional in the way that F# is, but you could do it. You absolutely could. In fact, as a challenge to yourself, try doing something like I have, which is take on the advent of code and write the entire thing in arrow functions. Only in pure arrow functions. It can be done. And if nothing else gets your head around functional programming, that will. Oh, okay. It's time to. So, okay. If I've got time for a last one, someone asked about big O complexity. In C#, probably it might well be pushing up the big O a little bit, but that's not necessarily my end goal. My end goal is not necessarily only towards efficiency and speed. My goal is maintainability and ease of reading, ease of maintenance. So those are more important to me than anything else. So sorry. Anyway, grab me on Slack or anywhere you would like, and I will answer as many questions as anyone has. But I think we need to wrap up now. Oh, someone says that's fantastic. Twice. Very kind of you. Thank you, Michael. Okay. Thank you very much, folks.